Assalamu alaikum. We are group 4 from section 1 of CSE331. Our course instructor is Dr. Dihan Mohammad Nuruddin sir. Our team consists of 3 members, including Mohammad Junaid Hassan, Humayra Anjum, and myself, Alif Ilham Khan. First, I will be talking about the structure of our project. We are using an Arduino Uno as our microcontroller here, which consists of 14 digital pins, and there are 6 analog pins, A0 to A5, and the digital pins are from 0 to 13. There are 4 ways we could power the microcontroller. We are powering our board through the USB port, as you can see here, which is connected to a laptop. The input power gets regulated to a 5-volt constant power supply and leaves through this pin. And from this pin, which is right next to this regulated 5-volt, we get the ground. And we have connected this to our breadboard. My other teammate will show the connections a bit later. First, I'll talk more about the structures. So we're using 4 LEDs here to show our inputs. And digital pin 4 to 7 are used for the input, and digital pin 8 to 11 are used for the output, which is shown in these 4 LEDs. And we are using 4 switches here to bridge the power supply that is coming from the Arduino board to the rest of the breadboard. And we use 4 resistors here so that our devices don't get damaged, our LEDs don't get damaged. Each of these resistors are of 10 kilo ohm. Next, my teammate will talk about the rest of the structure of this breadboard. Thank you.
Here we are connecting our input switches to the digital pins 8, 9, 10, 11, and we are observing the output through 4 LEDs which are connected to the digital pins 4, 5, 6, 7. Since we are implementing our 4-bit truth table, we have solved the outputs using 4 key maps. The Arduino board is programmed by using the free Arduino software, and we have compiled and uploaded the code to the board.
Here, the breadboard is powered by connecting the regulated 5-volt output from the Arduino board here, and this 5-volt regulated output is connected to the positive channel of the breadboard, and similarly, the ground of the Arduino board is connected to the negative channel of the breadboard. When a switch is turned on here, the breadboard is channeled to the Arduino board and the output is activated according to the program. We have measured the system power by measuring the current using a digital multimeter. I will show one measurement here. Here we can see that the current flow through the whole system for this specific input is 0.48 milliamperes from the multimeter here. And in this way we have calculated 16 currents and combined them with the 5-volt input to find the overall power used by this whole system. Now I will show the different inputs and the outputs as given in our K-map, in our truth table, and show that all 16 of them match our outputs. Here we can see that for our first combination, which is all zeros, we have the output 1001. When we have the second input, the output is 1000. For the third input, the output is 1011. For the fourth input, the output is 0101. For the fifth input, the output is 0101. For the sixth input, the output is 0100. For the seventh input, the output is 1011. For the eighth input, the output is 0101. For the ninth input, the output is 0011. For the 10th input, the output is 1011. For the 11th input, the output is 1101. For the 12th input, the output is 1100. For the 13th combination, we have output as all zeros. For the 14th combination, we have 0111. For the 15th combination, we have all zeros as our output, and as of all ones, which is the last input, we have our output as 1100. So we can see from here that our Arduino code is working perfectly, and we are getting the desired outputs from our given inputs. Thank you.
Now coming to the simulation part of our project, we have done the simulation and the hardware using two microcontrollers, namely Arduino Uno and the Arduino Nano. So I will show the inputs and outputs of our Arduino Uno and Nano respectively for 5 different inputs. So here, if we keep all the inputs 0, our output is 1001, which is consistent with our truth table. So if we give an output which is 0 in the I0 bit, the output gives 0011, which is also consistent with our truth table. Similarly, if we give I0 and I1 as 1, the output is all zeros, which is consistent with our truth table. If we give I0, I1 and I2 as 0, as 1, then our output is I0, I1, all the outputs are 0, and if all the input bits are 1, then all the output bits are 1100, which is consistent with our truth table. Coming to the Arduino Nano part, here if we have all the inputs switches as off, then we get 1001 as our input. If we have the I0 as 1, then we have 0011. If we have I0 and I1 as 1 and the rest 0, then we have 0000. If we have I0, I1 and I2 as 1 and I3 as 0, then we have 0000 as output. And finally, if we have all ones in the input, then we get 1100 as our output, which is all consistent with our truth table. So here we have used Arduino, we have used the free Arduino software and burnt the hex file in this Arduino Uno using this path, and we have also measured the total input current using this multimeter, and the detailed calculations are shown in the report. Similarly, for the Arduino Nano, we have burned the hex file into this Arduino Nano using this path, and after that we have been able to complete this project by perfectly executing the 4-bit truth table. That's all from us. Thank you very much.